Well, hi, good morning. Thank you so much for joining me here in my shop on June 8th. Yesterday, June 7th, I was in here and I did the usual thing. I did a whole pile of troubleshooting on this radio, trying to sort out what the weird behaviors were, turn the audio gain up, get weird oscillations and feedback. I hunted. I should say the last video, yeah, I should start a little differently here. The last video ended with me thinking one of the IF transformers was defective, but it didn't take me long yesterday to prove that that was not the case. There's no defective IF transformer in here. I did a whole pile of stuff yesterday. And then while I was getting the video ready, and I did not resolve anything, while I was getting the video ready, I got an email from, I think it's Tom. Thank you very much for the email. The email said, hey, you know what? There's supposed to be a jumper on the back of this radio. Oh, well, wait a minute. I know about that. I know about that. Right down here. So this is the terminal strip where you hook up your speaker. It's got 3 screws on it. One of them in the background is a ground. You can see the ground symbol there. This is the speaker output transformer, speaker feed coming down, passing through the headphone jack, and then down to the speaker here. And right here it says standby, and there's a dotted line running between these 2 terminals. And over here it says removable jumper. Okay. So here's what I concluded when I saw all that. One, well, the jumper's not in the radio, so it's probably something you put in to cause an action in the radio. That's what I thought. And what action would that be? That would be probably to silence it. So probably you would run a couple wires from here to your transmitter or something, and there would be a relay or something set up so that this thing would go dead when you go to transmit. That's what I thought. Well, I'm not transmitting, so shouldn't be any need for this standby piece to be put in. I don't want the radio in standby. I want it in operating. So, okay, so I thought that's just fine. It's not there, doesn't need to be there, and I moved on. Well, as it turns out, that's wrong. You do need the jumper there. And as pointed out to me by Tom, without a jumper there, there is no way, with the speaker connected between this terminal and this terminal, there is no way the speaker's making it to a grounded terminal. So you need this in here just to provide the ground for the speaker circuit. Okay, a lot of my video, which I did not post from yesterday, was me looking at this. I didn't look here. I'm looking here, studying this. This is the RF level control, and this schematic's done very poorly. The resistors are very hard to see. There's actually a variable resistor right there, or a potentiometer. Very hard to see on this schematic. Oh well. Okay, so, jumper, eh? So I put the jumper in. This is the jumper, this clip lead here, temporary jumper. And wouldn't you know it, the radio started operating. The feedback gone, the funny distortion's gone, and everything great, except no, not everything's great. The broadcast band is still silent. So what I'm going to do is I'm going to make this a little more permanent for the clip lead. Then we're going to play the radio. We're going to check each band, play it on, hook it up to an antenna, see what we pick up on each band, reassess that. And I think we're going to end up on the broadcast band with nothing happening. That's what I expect. And then we're back to it. We're back to it then. Why doesn't the broadcast band work? Okay, that's the whole story. Thank you very much, Tom. Otherwise I would have posted an email of me running around in circles, missing the point of it here. Okay, great. Let's get on with it here. Yeah. Okay, I've got the radio right side up, and we're going to give it a test on an antenna, and we're just going to see what is going on, since previously, without that link, a lot of crazy stuff was going on, really. kind of makes me wonder, what's this radio supposed to do with that link removed? Anyway, I'm not going to worry about that. Okay, we're just letting it warm up on the dim bulbs there for a little bit. Everything's fine. There we go. RF is full. Audio part way. And I'm probably on the broadcast band. So I'm going to switch. Yeah, I am. So we're on the 1.75 to 5 band. I'm going to skip the that's up full. It's 1.8 megahertz coming into. And that's the end of that band. Of course, nothing there. Not surprising. Next band up is basically 5 to 12.5 megahertz. And it's what time is it? It's 9 o'clock in the morning. Oh my gosh, it is only 9 in the morning. So wouldn't really expect to hear anything. Maybe at the top end. Maybe just up in this area here. Coming up on 9 megahertz. The radio went really quiet there. So this is around 7.3. Okay. Strong signals up in here. Where did the sound go? Okay, it's full volume now.
Exploring at the latter ray. So, would you, Miles, turn in your Bible for us to Acts chapter 2?
It's full blast.
4 verses for us.
Yeah,
I'm already there for you. And when the day of Pentecost was fully come,
it's a little better.
they were all with one accord in one place.
This is a very strong shortwave station we're listening to.
From heaven, as of a rushing
Okay, we'll go to the next band. This is 12 to 34, so we're starting at the high end, the 34. Full blast volume and everything. It kind of starts coming in. The CB guys here. So this might be channel 9. Channel 9, apparently people in Mexico like to use channel 9 all the time. So it's receiving. Fading in and out. Okay, let's carry on. In this area we might pick something up, 21 megahertz. I'd say no. And around 17 and around here. Let's listen to this for a bit. Doesn't sound very clear to me. Okay. Okay, down to the 19 megahertz. I'm sorry, 19 meter band. 15 megahertz. So again, although it's faded out, not very clear. Sounds like marbles. There's a string pop right there. String pop again. Again. We can check the accuracy of the dial now. You can see how close we are to 15. Just make sure that's about it. Now I haven't noticed this meter come up at any point in any of this. Let's keep going. Meter action. Meter full. Bandwidth is wide. Oh, that was a little odd.
No tenemos muchos argumentos hasta este momento que estamos desarrollando el programa, pero debería intentar plantear una menor edad entonces hay sido muchos
Not sure what to make of how this is going. Doesn't seem right though. Again, volume's turned up full. There we are. Okay, broadcast band. What is happening down there? Here we go. Whoa. Hit a little bit of a loud spot there. Well, I hear something. Strong station right here. So something is wrong with this band for sure. And then it goes quiet. Let's full. Oh. So we can hear it. 1010. It's there, but it's very weak. I wonder if everything that's going on here is just alignment. It's definitely there though. It's not dead. Oh, let's try this. That's why I think it's dead. Okay. Well, it's a totally different picture from what I've been working with up to this point. Alignment is probably what should be done. Certainly, if the alignment is off, there's nothing else I can do to make this better. And I can find out if the alignment's off without doing too much, without taking too much risk. There's a lot to it in this radio. Because there's two intermediate frequencies, two sets of intermediate frequency transformers, both operating at odd frequencies, 1650 and 50. but I think I can manage it. Now the radio is basically working. I don't think there's too much standing in my way of trying to do an alignment. That sounds like a good idea. Coffee time. When I was in grade 8, I came into class. We were on rotation, so my class rotated into our, I think it was our literature class. And on our desks was a piece of paper turned face down. And we all sat down at our desks, and the teacher said, "Don't touch the paper." So on my command, I want you to flip the paper over and answer every question, perform everything on this piece of paper. Make sure you read all the questions first, though, of course. Okay, begin. So we all turn over our page, and it says at the top, read all the questions before doing the test. And then number 1 is shout your name out. Number 2 is stand up beside your desk. And it's a whole series of about 10 stupid things. Number 11 was, now that you've read over all the questions, don't do anything. Just sit and watch all the students who didn't read the questions. And so I did it. I read all the questions. I saw the trick. I sat at my desk. I didn't move. I noticed 4 or 5 other students also not moving, just watching, while the rest of the class was jumping up and down and doing all this stupid stuff. And the lesson was, you should read everything. Read everything from start to finish. Apparently, I didn't learn the lesson, because here's the manual for the radio, and you've probably been staring at this part the whole time I've been talking. And right here it explains in very clear English what to do. Closed in receive, open in standby. Now I had this open all the time. You would think that if you open this, then the radio would go silent. But this radio doesn't go silent, it goes wonky. And so that unexpected result also encouraged me to not pay more attention to this, because if this were not right, then the radio would be silent, but it was never silent. So anyway, stuff happens. So, but what we really want to look at here in the manual is the alignment instructions, which I'm way down here somewhere are the alignment instructions. Operation, what's important? Calibration, the main tuning, be correct only, yeah. And we continue down. Oh boy, I really should read this. Here we are, alignment. It's been carefully aligned by specially trained personnel using precision equipment. Alignment should not be attempted until all other possible causes have been looked at. And I think that's where I am actually. Only by persons familiar with communications receivers and experience in alignment. Okay, I think I fit into there. We need a signal generator covering this range. I've got one. A vacuum tube voltmeter. I've got one. Here's the procedure. What's all this up here? Output meter. Connect output meter to appropriate speaker output terminals if a VTVM is used. Connected to terminals 3.2 speaker and ground, and terminate the output with a dummy load. Oh, if you don't put a load on. So I have a load resistor on the back here, so I'm all set. If I can put a VTVM on there. These controls, audio maximum, AM selectivity, as indicated in the chart. Band gangs half meshed. Well, during the first part, I guess. During the first part. And this is what I was trying to do before, and I'm going to try to do it again. Okay, here's what I set up. Signal generator, high side to alignment point A. I've done that. Low side to chassis. 50 kilohertz unmodulated. Okay, mine's modulated at the moment. I'll leave it like that. I'm on this band. I have a DC VTVM hooked up to this junction point. In the video I didn't post, I had all this set up and I couldn't get it to work properly. The voltmeter just sat on one reading the whole time. Maybe that'll be different today. Selectivity, 0.5. Okay, yeah, set that to 0.5. Okay, that's set to 0.5. Remove first conversion oscillator tube. I've done that. The tube is out. Adjust top slug of T6, 5, 4, and 3 for maximum indication. maintaining approximately 1 volt reading on DTVM. This is the problem. I don't think I got a volt there even now. When they say maintaining 1 volt, I think what they mean is you're turning down the input signal repeatedly to make sure this stays at 1 volt, doesn't go too high. Okay, let's see what happens this time. Let's see what happens here. Okay, so I've got here, I got the camera over here, trying to catch everything. I think I more or less succeeded there. So this is the meter we're going to be looking at. It's showing a below 0 reading right now. Let me just. This might need to be adjusted a few times. This meter drifts for quite a while. Okay, good. No voltage. We're on the 1 volt scale. The radio's not turned on. So this is the connection to test point A, I think this one is, or B, A or B, and this is the other B or A here. And I still have speakers connected, so we can listen for a little bit, but I'll probably have to disconnect them as we do this. Again, I got the modulation going. I'll turn it off, and I'll calibrate this. Oh my gosh, this is not happy. 148, 50. So there is a dial on here, and the dial says 50. So don't know what's going on with that reading. And we want to go 10 frames. I want to be like this when we go to do it. So we're set to 50. Set that there. We double check. I cannot get this to calibrate at all. Okay, won't worry about it. So the output multiplier set to 100. This is telling me it's around 3 microvolts, so 300 microvolts. There's no instruction on what it should be. We should just try to keep this guy at a volt. So maybe I'll knock this down, and here we go. Okay, so I've switched on the radio with the dim bulbs going, just to. Oh, look at this! Look at this guy! Oh, okay. 3 volt scale. So I guess it went way high at first. Oh, you didn't even see that. This thing was pinned right over on the 1 volt scale, but now it's not. So our 1 volt full scale, we're supposed to hold it there. At least I got a reading this time. Okay, we'll go for full voltage, no more dim bulbs. It's going down, down, down. Don't go down so far. Okay, let's turn the volumes up here so we can hear something. Hear absolutely nothing. Put this on here. Play me a little bit of sound, please. We should be able to hear this, shouldn't we? 50 kilohertz going in there. RF gain's full, but I don't think it matters, but it is full, and the audio is full. Well, we're on this tight bandwidth setting. Whoops, turn the set off. Let's open up the bandwidth here. Okay, still don't hear it. We'll increase the output here. Pretty high now. It's still at 50. This meter's doing nothing. Nothing's doing anything. Okay. So the tuning capacitors were supposed to be about their mid, which I didn't bother doing. Probably not very critical, but I'll do it now. Okay, both tuning capacitors are in their midpoint. We still got nothing coming out of here. Can't very well align it like this. So I'm going to vary the frequency and find out if maybe it's off. Hopefully we'll hear something come out of the speaker. The speaker's hooked up. Yes, yes, yes. Yes, yes, yes. We've been hearing stuff. Huh? You hear it? 52. This is going on. Let me put this up another. We're giving it a chunk now. Literally birds in there. This meter is just doing nothing. It's going the wrong way, if anything. Huh. How am I supposed to work with this? So this is not working out at all. So we could switch to just monitoring the speaker volume. I'm really quite upset that this is not working. How come you're not working, man? This is done. I even checked my clip lead. Clip lead's good. Let's turn off the modulation. I'm supposed to do this with no modulation. Okay, Mr. Meter, here's your chance. Meter goes down as we tune this in. This is not for the unmodulated signal, we cannot listen to the result coming out of the speaker. There's no result. So I have to pick up the signal somewhere where it's being detected and turned into DC, which is what this test point A is, which is what my meter is connected to. We're getting nothing on the meter at all, and it's warning us to keep it down to a volt. Yeah, I've got this thing wide open here. I don't know. I am sending over a very strong signal from the signal generator. I have picked the wrong, you know what? I think I'm on the wrong spot. Let's take a look here. I think I've picked the wrong, I think I accidentally should be up here, not down here. I think that's what I've done wrong. We take this guy here, like that. We say here's test point A. It's below the bar. Yeah, it's below the bar. Test point, no, it's correct. Alignment point A. You can see the diagram I'm using is a little bit questionable about seeing exactly what's going on, but I studied this very carefully and studied the schematic and really deduced without any doubt where these points are. Yet she's not working. What if I do this on another band? Because this band's a little weird. Does it say which band to do this on? I think it says to do it on the broadcast band. But let's try another band. So let me turn this down. Where's the band switch? That's another band. Just go up a little bit. No? No, this is probably drifting. No, there's something there. A little tiny bit there. What have we done here? We haven't done anything. RF backup, audio backup. So I can hear a hiss coming out of the speaker there, very, very quiet. Okay, once again we'll adjust the frequency here. Okay, and the meter's going down, not up. Meter's going down, not up. Oh boy, you know, you gotta make you gotta have good feelings about stuff like this before starting to fool around with the alignment. And I do not have good feelings about this at all. It seems to me we're putting the signal in where it should be coming out. Isn't this the start? Come down through here? I guess not. I think it comes around like this. The signal comes around like this and then heads back that way. So this would be 5. This would be like this. So we have T 1, 2, 3, 4, 5, 6. It goes in this order. And I'm supposed to be adjusting. I think it was 4. I'm reading in 4, 3, 2, and 1. Are they so far out that this is what's happening? Oh my gosh. Yeah, break time. It's break time, that's for sure. I gotta take a little break here. I don't like this. Things are not adding up. Once again, jeepers. Let's take a look at the schematic here and see what point A really is. So here's point B. Point B is the test point that I've got the voltmeter hooked up to. So it's an AM detector. Well, better hold this over here. AM detector. In fact, why don't you look down this way a little bit? Oh, I see what's happened. My camera is coming loose here. Okay, point B is right next to the AM detector. So, and you can see it's actually on the output. This is the input to the detector coming along here. So it gets rectified here, and from then on it's a DC sort of deal going on in here. So this is exactly where you'd want to hook up a DC voltmeter, right here, right where they're showing it. If I just get on the other side of this 1 meg resistor here, right on the output of this. This is the AM detector. This is what we're hearing. So we've heard this work because we've heard voices come out of the radio. So we know this is working. And they must have another detector here, AVC rectifier. And over here, what's this? AVC amplifier. Yeah, I studied this myself a bit. I'm not completely understanding what they're doing here, but we can assume they're somehow amplifying the AVC voltage. I don't know. But I don't think it has anything to do with what's happening over here. So I think I'm going to move the probe from here to the other side of the 1 meg resistor and see what shows up. Maybe it's open. Not very likely. Maybe a short on this capacitor. Again, not very likely. And because we've been hearing the radio, but the radio's very quiet. I had the volume turned up very high all the time. So a couple things adding up there. Low output volume and apparently no DC being developed here. We could be onto something. So let me move this to the other side. It's pretty easy to do. The radio is on. That's the resistor right there. And we just go to the other side here. So my meter shot negative there. Let's put it on negative setting. That's what I would expect, is a negative here. Oh yeah. But on this side, oh no. Hey, I think we found something. Let's go on this side. Okay, I heard something come out of the speaker there just briefly. Oh my gosh, I'm so sorry about my camera's tipping around here on its own. Okay, now we can see the meter. See, the meter is up. So I moved my clip lead, this one, yellow one, to the other side of this resistor. That's all I've done. It's gone from, where are you? I've just gone from the test point here to the other side here. So at this point, so you know what, this is implicating this capacitor as being shorted. That's what this is all implicating. There's a diode here. What's the diode for? What's the diode for? Because it's got this. What's this? Maybe this is, no, oh, automatic noise limiting. This is probably a noise limiting diode they've put in here. Gives you an idea of the kind of voltages they expect operating in here, around a volt. Any higher and this thing will start conducting. I think that's what they've done. Oh, these crafty people. So for right now, the noise limiter is off. Okay, let's see what happens now as I move the to this voltage and I move the frequency around a bit. Oh, you know what? There is no frequency. I turned this off while I was drinking coffee. So what is causing this? Not an input signal. Let's see what happens as the signal comes up. Okay, it's there now. 50, 52. This is doing nothing, sitting in one spot. This is half a volt roughly here. Okay, I'm going to tune the signal generator around a bit and we'll see what happens to this. Okay, it's going up. It's a broad range. Right through the 50. Down to 53. I still have the EBGBs about this. Why would we get a voltage here, but on the other side we get nothing? So here we see this voltage happening. The voltage has to be coming from the detector, does it not? Where else could it come from? It's a negative voltage too. Where else could it come from? It's got to be coming out of this detector. But it never falls to zero. Never falls to zero. What if I tune the radio a little bit? Having no effect. My input level is too high. Maybe it's too high. Knock it way down. What do we got now? Now you don't see the effect. It's not enough to cause any effect. I don't like it. Don't like what's happening here. So I'm going to spend some time studying this and trying to understand this better. Just what exactly they're trying to pull off here. I don't think it's anything too complicated. Just take a little bit of time to study it. Because I'm not getting anywhere. I barely got a sip of coffee. I got an idea. So there's two detectors in this radio. It's a little bit unusual. There's an AM detector down here. And then there's a product detector up here. You can switch between them by switching from AM to single sideband. So if I switch to single sideband, the radio will be listening to the output up here. instead of listening to what's going on down here. And my past experience with this radio is it's a big difference. So why don't we experiment with that? We'll say, never mind what's happening here. What about what's happening up here? So that's a simple matter. Turning down the volume, flipping to the other detector. Okay, now this engages the beat frequency oscillator, which you can hear. And the tuning should not affect it because I'm pumping the signal in here. Not much of a signal. I mean, the volume's full. We're not doing well at all in terms of that. Let me change the bandwidth. 5. It's a wider bandwidth. Nope, not making much difference. Tune this guy now. It's so muted. I think you hear the hum because I've got the volume turned up full here. Why is this not working? So I'm pumping 50, maybe it's not high enough. Let's try that. Turn the volume a little bit. I mean, this should be really producing a loud output, I would imagine. I'm not watching this meter. Maybe you are, I'm not. Well, that's pretty nice. That's kind of what you would expect. Except this bottom point is just based on where the BFO is set. And that's random. I've got it set in the middle, but I don't know that it's adjusted in any way correct. That's the middle there. Okay, so what if I forget this, trying to do this using this method? Why don't we just modulate the thing and listen to the audio coming out? So just in case. Okay. So we're modulating at 1,000. Ooh. We're on single sideband. Okay, we don't need to be on single sideband. We'll go to AM again. Back to the other detector. There's nothing. There's nothing. Next to nothing. Barely audible. Barely audible. And like I said before, there's no information on how strong the signal should be you're putting into the radio, other than to say it should be enough to generate the voltage over here. So this is showing a negative voltage right now, which would be expected. But I would think this would drop to 0 or close to it when you're off frequency. Or off frequency and nothing happens. And if we go from this point to the proper test point, the declared test point, it's gone the other way. Also, it doesn't say in the instructions what voltage to expect, but you would expect a negative there, I would think. Let's tune around here. There's just no movement in that meter. So, one of the things about doing alignment at this stage in a radio repair is it can, stumble into difficulties with the radio, like deficiencies in the radio, but it can also highlight deficiencies in the radio. Otherwise, how are you going to know that anything's wrong? Because it doesn't work at all. What band am I on? I think I'm on the troublesome band here, are I not? IR. Let's go on the not so troublesome band. Next one up. That didn't make a hill of beans worth of difference. Nothing happening on the meter over here. Nothing at all. Nothing at all. Come on. I don't know what's going on. So my idea of switching over to here didn't, what I was hoping for was a screamingly loud output. So that would indicate this is working, this is not. But instead, I kind of got a low output out of both. But that suggests the problem is further up in the radio. Could it be just a really, really bad alignment? Well, the answer is yes, it could be. I mean, how do I know? I don't know at this point. A really, really bad alignment in here. So that means I should start twiddling the alignment adjustments to see what happens. I haven't touched them to this point. I don't know what else to do, so let's try that. Because I think everything is normal, everything is hooked up correctly, everything is going the way it's supposed to go, but it's not going the way it's supposed to go. So let us try the alignment. Now I think I start with, I have to check, was it 5 or did I start with 4? Just bear with me here a minute while I take a peek at, while I try to click the right thing on my booter. 6, 5, 4, and 3. 6, 5, 4, and 3. Starting with 6. Starting with 6. So this is actually like that. We have the 3 going across up here. 1. Where are they? Oh, I've got the radio the other way around. Like this. Like this. So we're actually... Oh my god, I'm totally confused here. So we're looking down from the top. It would be like that. We want to find number 6. Which would be here. And we should find 1, 2, and then 2 more in the middle. There we are. 1, 2, 2 more. Oh! That's right. Turned upside down. Oh, backwards. 6, 5, 4, 3. 6, 5, 4, 3. Okay, I got it. Now we got to look at the other side of the radio, which would be a lot easier because I'm looking at the bottom when I don't need to. I'm confusing myself unnecessarily. I need no assistance in that department. Okay, here we are. Now we're looking at the business end here. So in this case, this just lines right up like this. 6, 5, 4, and 3. Oh, what's special about that? Huh? I may have found something right there. That's kind of weird. This is all... Would appear that this is grounded, but maybe not. Maybe this part's actually floating in here. None of the other ones make any sound. Yeah, I got a tube out still. I've got an oscillator tube out. I think that's okay. It's supposed to reduce interference at this point. I think it's still fine. So we'll start. We'll start with number 6. Number 6 is this one. What can we do with that? Okay, so we're around 50 on the signal generator, and I can barely hear this. Whew. No difference. Why did we skip to the one that's acting up? Oh, a bunch of corrosion just came out of there. Oh, it scared myself. Been a while since these have been turned. Is it corrosion, or it could be a locking fluid? There's nothing happening here. I don't like it. I don't like it one bit. I don't like the situation. I'm on my way to just messing this up, something terrible, without realizing it, and this is not working out at all. Not at all. I'm not hearing an increase in volume. I can barely hear it. And everything is turned up. Everything is turned up except for this. I can do that. What's that do to this meter? It's dipping down again. Do these make any difference at all? Oh my, they don't. Yeah, there's a difference there, but this is not how you do an alignment, by the way. This is how you mess it up. There's no dramatic change here at all. I'm doing something completely wrong. You know, doesn't it start with 1650? It doesn't start with 50. It starts with 1650. And he's looking. 50. It says no, it starts with 50. Oh, wait a minute. So 50's at the tail end of things here. Let me just turn off the whine. 50's at the tail end. The start is 1650. Am I at the tail end? T with numbers like T 1 2 3 4 5 6. That's it. That's at the tail end. Wouldn't that be at the start? So maybe it's 1650, 1650, then a conversion, and then 5050. 4 of them at 50? 4 of them at 50? Come along here, and we see 1650, 1650, and we get to 50. So it'll be 50, 50, 50, and 50. Yeah, there's 4 of them. 6, 5, 4, and 3. So we are in the right place. We are doing the right thing. We're feeding in the signal at point A here. So it is just going through the 50 part. What if we let this is at 1700. What if I feed in a 1750 here, or 1650 rather, what would normally be coming out of here? Why wouldn't I feed a 1650 into here? Then let the converter convert it to 50. Why wouldn't it be like that? Sorry if I'm not showing you the schematic clearly, but let's try it. We'll go to 1650. I'll turn this down. 1650, so I'm presenting, what am I doing now? I'm presenting 1650 to this mixer tube. It's just exactly what it's supposed to get. Okay. Okay, so you're sneaking a 50 in there now. We're going to give it the what it really wants to drink down. 1650. Ho, 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 ho. Hot diggity dog, this meter's going like crazy too. Oh, okay. Follow the instructions doesn't work. Think about it myself and it seems to work. Oh my gosh. Okay, turn this down. Tune it in. It's pretty much right on the money. So maybe what's the problem with doing this? The problem with doing this is you're converting it in an unknown way. I mean, supposedly it's a crystal running at exactly 1700, 50 away from 1650. But it may not be at 1700. Maybe slightly higher, slightly lower, who knows? I know, I can find out. So, and I can adjust that a little bit, I think. So if we are doing, let me turn this off, 1650, well, certainly that's going to, that's going to deter, let's do it. The heck with thinking about it. Too much thinking going on here. I'm feeling much better. So we're going to watch this meter now. It's going down again. 1648, that would be 1650. My counter's a little off. So I think that's okay. Now we'll try adjusting these things and see what happens. Starting with, which way is number 6? 6 is this guy. Nothing happening. I'm watching this meter over here. What am I doing wrong now? That didn't do a thing. I have too much signal coming into the radio. Maybe that's the problem. That's going up and down. Oh, you know what? This is going down as I seem to be closing in on the target. Well, just keep doing things completely backwards from what they instructed. This guy's not doing anything, really. I hope I'm not messing everything up. I think maybe it's too much signal coming in. So the meter's moving just ever so slightly here. Let's knock down the signal. So I'm supposed to be doing this with that unmodulated signal also. I'm going to bump it up another notch. Wow, did you see that? Now we're cooking. So this is almost a volt now. Well, let's try this whole thing again. No modulation. There we go. Hey, now it's behaving properly. Would appear to be behaving properly. So if we do it. Now, one of the things I've learned in doing this work is the first time you do an alignment is pretty much a write-off to education. See? You always pay a price for education. Yeah, look at that. Nice peak showing up now. Hear what I said? You always pay a price for education, no matter how it takes place. A price is paid. Yeah. Well, we're up over a volt. So we can knock it down this way. That's the spot. Right there. So now, how far out was this? Well, it wasn't really out at all, I don't think. There's a sharp peak on this one. Okay, got the good feelings here. Now, how do we know for sure that I just did it at 50? We're going to use the SDR to verify the frequency I just did that at. But I'm going to celebrate with a little sip of coffee. So I have my SDR operating. This is the SDR antenna or pickup loop. It's just a clip lead. And I'm just going to put it in the radio roughly around here where I can sense the frequency coming out of the signal generator. We can double check it and make it more accurate this way. Okay, we'll look at the SDR here. Okay, I've got it zoomed in on 1650. 1650 is where the red line is here. And I'm going to put the coil in, the spot I showed you, and there we are. So now I'm going to adjust my signal generator rate to exactly 1650. Okay, that's precisely about as precisely as I can get it. 1650. Now we're going to make those adjustments. I'm going to go back to the camera here. Okay, try again making the adjustments. On the meter. Did I turn this down from here? No, it's because I've tuned things. That's why the meter's dropped. Okay. Back to doing the... which way did I turn this radio? I turned it this way. Round and around. Round we go. Where we stop? Right here. Okay, probably hard for you to see the movement on that meter, but it is moving. Keep it under a volt. I can give it more. Ooh, the signal generator drifted a bit there. Let's just leave it where it is. You can see the meter moving. You can certainly see that. Oh my. Holy smokes. Really? Yeah, that's a peak there. Wow, let's go back to the first one. Really can't see much of a peak here except it goes down. So we're going to go up here. Like that. Okay, we'll go to the next one. Right there. Holy smokes. Okay, you hear the sound change in the speaker too. Okay, 1 volt, 1 volt. Well, we pretty much got it where it's supposed to go, it seems. I mean, the 1 volt is reflective of what I'm sticking into the radio. Should double check to make sure this is still at 1650. I'm just going to do that on my own here. I'm going to take a look, see. Show me a 1650 here, somebody. I have to go around the back to see it. No, it's there. It's right on the money. Very good. Okay, so I put in 1650. I let the converter tube with the crystal convert 1650 to 50. How do we know it converted it to 50? I don't know. I'm thinking, again, first time through, it's all education. Although I think we got a good result here. Finally, after a lot of craziness, really, a lot of craziness. I guess if they were to write the instructions sufficient to take anybody through any difficulties that they might have, it would be a very long document. And maybe, this is where experience comes in. I'm getting it. I'm getting some experience here. Okay, I think I'm going to leave it at that. Tomorrow, we'll try the next alignment step. Ooh, maybe we should listen to the radio a bit before I pack it away. Let's do that. So I'm going to shut this guy off. Shut that guy off too. Ooh, this isn't an antenna connection, Jim. Don't do that. Just leave that hanging out there. And okay, going out to my outdoor active antenna. And then we want to hook it up to the antenna terminals, so we'll just use the ones on the back here. This is just a ground. Can there no other place? There's no other place. I find these are just like you hear it. These are surprisingly bad. These screw connections. Take off this connection here, and we should take off this one too. Fingers in a live radio there, Jim. Just put that there like that. So there's no connections into the back of the radio now. Just an antenna connection. I would go around this way. We go all the way around, and we cannot. Whoops. Clip leads. Okay, man. Here's your another chance. Let's just see what's going on. Audio full, RF full. Oh, let me see. This should be screaming, right? It should be screaming out right now. So we're going to second band up. It's as quiet as can be. Why? I can hear something there. But not on the AM band. We're up. Jim, you ruined the radio. Put this back on its set point. Here, and we'll go up to a band that we expect to be working at this time of day. Could be here. There's just nothing. What did you do to it? Boy, it sure seemed like I was doing a good thing to it. Not now. That's definitely up full. Okay, let's go to the 9, this powerful station at 9. So we want to be on that band, not right in here. Well, I've killed it. Do something dumb. Did I hook up? No? Well, there you are. Okay. 2 thumbs up on the alignment. You know, it's a classic case of the operation went fine, but the patient died. That's basically where we're at here. I don't know what's going on. Oh my gosh. Okay, well that's it for today. I brought it back to life and then subsequently killed it somehow. We'll leave it at that. Thanks a lot for watching. Tomorrow I'm just going to plug away on this thing. Sooner or later, you know, the sunlight will break through the clouds and this radio will work fantastic at some point. Thanks a lot for watching, and see you on the next video.